So remember last time we were talking about the graphs of parent functions, right? And we did most of them. I think we got 7 of the 8, and we just didn't get to the log function. Okay, the log function is kind of a weird one. And honestly, we're probably not going to deal with the exponential and log functions much, if at all, this year. We're just a little bit behind, because of distance learning. Not very far. We're just a tiny bit behind where we normally would be. And I'm just not sure if we're going to get to those topics. But those are kind of almost optional topics in Algebra 2. You're going to see those next year a bunch anyway. So I'm not sure how much we'll do with this, but you'll for sure see it quite a bit next year, if not this year. And so I want you to be familiar with it. Okay. So we're going to do, for our log function, we're going to use what's called the natural log function. We can do a common log, which is a base 10 log. We could do a base 2 log. We can do all different kinds of logarithmic functions. This just means the base is the natural number e. But none of that stuff is really very important because the shapes are all the same, and that's really all we're going for here. So this would be f of x equals, and it's just like a cursive or a script, ln for natural log of x. There are some other kinds of logs we could do. Like if you've probably maybe seen something like this on your calculator before. We could do a base 10 log of x if we wanted to. But we're just going to do this one. They all look essentially the same though. Here's what they look like. All log functions have this in common. They all go through the point 1, 0, and they all look essentially like this. They start off growing very rapidly, and then they slow down as x increases. They're sort of the opposite of an exponential function. In fact, they're inverses. They do opposite stuff. An exponential function grows very slowly for negative values of x, and then as x becomes positive, it starts to pick up steam. And you've heard the expression, it's increasing exponentially or something, right? Meaning it's just getting out of control. It's growing so fast. Log function does the opposite. Log function for very small positive values of x, it's growing extremely fast, but then as x increases, it really slows down. It starts to grow very slowly. Okay, so what's the domain in the range? Let's just kind of get through the fill in the blanks on our template here. So what's the domain then? I want you to notice something here. Notice that this function, it seems to have one of those asymptotes, doesn't it? It's got an asymptote on the y-axis. And remember, an asymptote is just a line that the function approaches but never gets to, right? So we've got this vertical asymptote right there. It's the y-axis, which means it's just the equation x equals 0, okay? It's got an asymptote at x equals 0. So what's that make the domain then? What are all of the x values graphed on this function? In other words, what are the x values that x coordinates an ant could ever stand on? Go ahead and type it in chat for me, please. What's the domain here? What do you think? Type it in chat for me. All real is a suggestion. Well, does it look like there's any negative values of x ever graphed there? Whole numbers? Okay, the whole numbers are included, but look at these values right here. The ant could be walking along, and it could have values like, it looks like x could equal 0.5 or 1.1 or 1.5, or right? So it's not just whole numbers. Okay, it goes up to positive infinity. So I will agree with you on that. The domain, the right endpoint of the domain is positive infinity. But what's the left endpoint of the domain? If we want to write this using interval notation, what's the smallest x value? Okay, 0. All right, so it looks like it goes from 0 to infinity, right? Does it ever get to 0? We've got this asymptote here. Can the ant ever have an x value of 0? Yes or no, everybody? Not getting many answers. There we go. No, it can't, right? Because there's an asymptote there. As the ant moves closer and closer and closer to 0, it's getting deflected down, right? Further and further and further down. The slope just gets steeper and steeper, so it can never actually get to 0, right? So here's the domain. It's all values of x greater than 0, so all positive numbers, but not 0 and not the negatives. Okay, what about the range? Keep in mind here that as the ant moves to the right, yeah, the function starts to grow more slowly, but it's always growing. As he goes to the right, the function continues to rise forever. Okay, so I'm seeing some infinities. What's it going to look like? So how would I say that? How do I say the range? Okay. I'm seeing some people saying all reals. That's correct. There's no y value that the ant couldn't step on, right? This function goes down to infinity as x pushes up towards 0 from the right. As an ant walks backwards towards x equals 0, it just keeps going down forever. As an ant walks to the right forever, he's going to continue to grow upward on the function. The function is going to carry him upward slowly, but if you're going forever to the right, there's no y value you couldn't get to if you went far enough. So the range is all reals. What about the end behavior? As x approaches infinity, right? Meaning as the ant goes to the right forever, what's the y value doing, right? As the ant goes to the right forever, what's he doing vertically? Okay, everybody type it in for me. What should f of x be approaching? F of x just y, right? Just fancy name for y. As x approaches infinity, f of x or y approaches what? Type it in chat for me. Yeah, there we go. Okay, infinity, perfect. Okay, the other end behavior is a little strange. The ant can't approach negative infinity because we've got this wall here, right? We've got this vertical asymptote that he can never get to, okay? So the best he can do is approach 0. He can't actually ever get to 0, right? But he could approach 0. As the ant is approaching 0, what's happening to f of x? What are his y values approaching? Type it in chat. As x approaches 0, okay, let me hear from everybody. Okay, there we go. Yeah, negative infinity. How about that? Because it's going down forever. Is the function continuous? Yeah, it is. I can graph this whole thing without picking my pen off the board. Okay, good. All right, so there's the end of our notes for, it's going to end up being assignment. So it's going to be problem set. It'd be 3.2 practice 1. Okay, that's everything we need for 3.2 practice 1. Okay, I want to just get a quick start on 3.2 practice 2. And then we're a little bit ahead, so there's a pretty good chance on Thursday you guys could get we'll see how far I get in my other classes, but you'll at least get a pretty good chunk of time to work on Thursday, I think, in this class.